Chapter 3. Motion in a plane. Exercises pages 44 to 46. Exercises Q1. Page 44. Choose the correct option. An object thrown from a moving bus is an example of underscore. 1. Uniform circular motion. 2. Rectilinear motion. 3. Projectile motion. 4. Motion in one dimension. Solution. An object thrown from a moving bus is an example of projectile motion. Exercises Q1. Page 44. Choose the correct option. For a particle having a uniform circular motion, which of the following is constant? 1. Speed. 2. Acceleration. 3. Velocity. 4. Displacement. Solution. Speed. Exercises Q1. Page 44. Choose the correct option. The bob of a conical pendulum undergoes 1. Rectilinear motion in horizontal plane. 2. Uniform motion in a horizontal circle. 3. Uniform motion in a vertical circle. 4. Rectilinear motion in vertical circle. Solution. Uniform motion in a horizontal circle. Exercises Q1. IV page 44. Choose the correct option. For uniform acceleration in rectilinear motion, which of the following is not correct? 1. Velocity time graph is linear. 2. Acceleration is the slope of velocity time graph. 3. The area under the velocity time graph equals displacement. 4. Velocity time graph is nonlinear. Solution. Velocity time graph is nonlinear. Solution. Exercises Q2. Page 45. Answer the following question. Separate the following in groups of scalar and vectors. Velocity, speed, displacement, work done, force, power, energy, acceleration, electric charge, angular velocity. Solution. Scalars, vectors, speed, work done, power, energy, electric charge. Velocity, displacement, force, acceleration, angular velocity, pseudovector. Exercises Q2. Page 45. Answer the following question. Define average velocity and instantaneous velocity. When are they same? Solution. Exercises Q2. Page 45. Answer the following question. Define free fall. Solution. The motion of any object under the influence of gravity alone is called as free fall. Exercises Q2. IV page 45. Answer the following question. If the motion of an object is described by x equals ft, write formulae for instantaneous velocity and acceleration. Solution. Exercises Q2. Page 45. Answer the following question. Derive equations of motion for a particle moving in a plane and show that the motion can be resolved in two independent motions in mutually perpendicular directions. Solution. 4. Equations 1 and 2 can be resolved into their x and y components so as to get corresponding scalar equations as follows. 5. It can be seen that equations 3 and 5 involve only the x components of displacement, velocity and acceleration, while equations 4 and 6 involve only the y components of these quantities. 6. Thus, the motion along the x direction of the object is completely controlled by the x components of velocity and acceleration, while that along the y direction is completely controlled by the y components of these quantities. 7. This shows that the two sets of equations are independent of each other and can be solved independently. Exercises Q2. Page 45. Answer the following question. Derive equations of motion graphically for a particle having uniform acceleration, moving along a straight line. Solution. 1. Consider an object starting from position x equals 0 at time t equals 0. Let the velocity at time t equals o, and t be u and versus respectively. Exercises Q2. Page 45. Answer the following question. Derive the formula for the range and maximum height achieved by a projectile thrown from the origin with initial velocity u at an angle theta to the horizontal. Solution. Exercises Q2. Page 45. Answer the following question. Show that the path of a projectile is a parabola. Solution. Exercises Q2. X page 45. Answer the following question. What is a conical pendulum? Solution. A simple pendulum, which is given such a motion that the bob describes a horizontal circle and the string making a constant angle with the vertical describes a cone, is called a conical pendulum. Exercises Q2. X page 45. Answer the following question. Define angular velocity. Solution. Angular velocity of a particle is the rate of change of angular displacement. Exercises Q2. Sheet page 45. Answer the following question. Show that the centripetal force on a particle undergoing uniform circular motion is Mr. Omega 2. Exercises Q3. I page 45. Solve the following problem. An aeroplane has a run of 500 meters to take off from the runway. It starts from rest and moves with constant acceleration to cover the runway in 30 seconds. What is the velocity of the aeroplane at the takeoff? Solution. Exercises Q3. Page 45. Solve the following problem. A car moving along a straight road with a speed of 120 km per hour is brought to rest by applying brakes. The car covers a distance of 100 meters before it stops. Calculate I, the average retardation of the car, E, time taken by the car to come to rest. Solution. Exercises Q3. Page 45. Solve the following problem. A car travels at a speed of 50 km per hour for 30 minutes, at 30 km per hour for next 15 minutes and then 70 km per hour for next 45 minutes. What is the average speed of the car? Solution. Solution. Exercises Q3. Page 45. Solve the following problem. A man throws a ball to maximum horizontal distance of 80 meters. Calculate the maximum height reached. Solution. Exercises Q3. Page 45. Solve the following problem. A particle is projected with speed v0 at angle theta to the horizontal on an inclined surface making an angle phi less than theta to the horizontal. Find the range of the projectile along the inclined surface. Solution. Exercises Q3. Page 45. Solve the following problem. A metro train runs from station A to B to C. It takes 4 minutes in traveling from station A to station B. The train halts at station B for 20 s. Then it starts at station B and reaches station C in next 3 minutes. At the start, the train accelerates for 10 seconds to reach a constant speed of 72 km per hour. The train moving at the constant speed is brought to rest in 10 seconds. At the next station, I plot the velocity time graph for the train traveling from station A to B to C. Calculate the distance between the stations A, B and C. Solution. The metro train travels from station A to station B in 4 minutes equals 240 s. The train halts at station B for 20 s. The train travels from station B to station C in 3 minutes equals 180 s. Therefore, total time taken by the metro train in traveling from station A to B to C equals 240 plus 20 plus 180 equals 440 s. At start, the train accelerates for 10 seconds to reach a constant speed of 72 km per hour equals 20 meters per second. The train moving is brought to rest in 10 s at next station. The velocity time graph for the train traveling from station A to B to C is as follows. Distance traveled by the train from station A to station B equals area of PQRS. Exercises Q3. Page 46. Solve the following problem. A train is moving eastward at 10 meters sec. A waiter is walking eastward at 1.2 meters sec. And a fly is charging toward the north across the waiter's tray at 2 meters per second. What is the velocity of the fly relative to Earth? Solution. Exercises Q3. Page 46. Solve the following problem. A car moves in a circle at a constant speed of 50 meters per second and completes 1 revolution in 40 s. Determine the magnitude of the acceleration of the car. Solution 1. Solution 2. Exercises Q3. X page 46. Solve the following problem. A particle moves in a circle with constant speed of 15 meters per second. The radius of the circle is 2 meters. Determine the centripetal acceleration of the particle. Solution. Exercises Q3. Sheet page 46. Solve the following problem. A projectile is thrown at an angle of 30 degrees to the horizontal. What should be the range of initial velocity, u, so that its range will be between 40 meters and 50 meters? Assume g equals 10 meters s2. Solution.